Okay, so reviewing for test 1. Okay, the first couple of problems are going to be what we did at the very beginning of the semester, where it gives us an equation and asks us to graph it by plotting points. So you have 6y plus 3x equals 6. Now remember, when you're doing this, the easiest thing is to put it in your y equals. Well, if you're going to put it in your y equals, you have to know what y equals, right? You need your y by itself. So the first thing you're going to do on this one is isolate this y. So you're going to subtract the 3x from both sides. So now you have 6y equals. Now remember, on the right side, since those are not like terms, you can't put them together. You're just going to bring them down separately. It doesn't even matter who goes first and who goes second. I always just put my x in front of my constant. So I'll have the minus 3x plus 6. And then you're going to divide everything by the 6 to get rid of that 6. So now you have y equals negative 3/6, which will reduce to negative 1/2 x, plus 6 over 6 is 1. So that's what you're going to put in your y equals is negative 1/2 x plus 1. So you'll go to y equals negative 1 over 2 x plus 1. So just like that. Then remember, when you're graphing in Math Lab, the first thing you're going to have to do is tell Math Lab what shape you're drawing, right? So if I hit graph, it'll tell me that. It'll tell you the shape. And since x is just an x, it's going to be a straight line. Now I need some points. So I hit the second table button and then just choose any points from that table to graph this line. I would just avoid points that have decimals. So let's see if I do negative 2, positive 2, and 0, 1. And remember, when you're graphing a line, it's just going to ask you to plot 2 points. Once you plot that second point, it's going to connect them for you. So negative 2, positive 2 will be to the left 2, then up 2. 0, 1, which means left and right 0, up 1, and then connect. All right, number 2, same kind of graph, or not the same kind of graph, another graph, y equals x squared plus 3. Okay, so on this one, the y is already by itself. So I can go ahead and put that in my y equals. It's an x squared graph, which means it is going to be a parabola. So if you go to y equals, clear it out, type in x squared plus 3. And again, if you're unsure, just hit the graph button to see its shape so that you can tell Math Lab that it's a parabola. And then again, second table, and then choose some points from your table. So negative 1 goes with 4. 0 goes with 3. You're only going to have to plot 2, but just so you can see that rounding out right there, I'm going to plot this last point. So left 1, up 4. Left and right 0, up 3. And then to the right 1 and up 4. And connect them. Number 3 is an absolute value graph. It's going to be y equals the absolute value of x minus 2. So again, I would just go straight to y equals, get some points. And remember how to get to absolute value. You hit the right math button. And then go over to that NUM for number. The first thing under that is going to be ABS or absolute value. So hit enter, and that'll give you your absolute value. That'll give you your absolute value bars. So inside there, just type in x minus 2. And then graph it. Now, remember, when you're graphing absolute values, it's different from all the other graphs. Usually the yellow rectangle up top says plot point or plot your first point or something like this. This one's going to say plot the vertex. The vertex of your absolute value is that point on the V. So if I look at this, the first point I'm going to have to plot is where my x is 2, right? Because it comes down and touches that x-axis at positive 2. So when I go to my table, the first point I'm going to have to plot is when the x is 2. When the x is 2, y is 0, and then I'm going to plot a point on either side of that. So above it is 1, 1, and below it is 3, 1. So that'll give me the vertex and 2 other points. So to the right 2, up and down 0. Right 1, up 1. And the last point is right 3, up 1, and then it'll connect them. All right, the next one is going to give us a domain column and a range column, and ask us if the correspondence is a function or not. Now remember, in order to be a function, each element in your domain can only go to one element in your range, okay? So if my domain is -1, +1, 8, and my range is 2, and each one of those goes to 2, but don't let this fool you. The first thing you have to look at is your domain and see if anything in the domain goes to 2 separate numbers. Right, none of these do, right? No, -1 only goes to 1 number. +1 only goes to 1 number. And 8 only goes to 1 number, right? So that means, yes, it is a function. Because each element in domain only corresponds to 1 element in the range. Right? Number 5. Number 5 is going to give us a function and then want us to find 3 different function values in that function. So we're just going to be plugging in for the x. The function it wants us to use is f of x equals 3x squared minus 4x. So it's going to give us this function, f of x equals 3x squared minus 4x. I think you'll see it once I put it up here. The first thing it wants us to find is f of 0. Which tells me what? Whatever's in this parentheses is what I replace these x's with and find that value. So I have 3 times 0 squared minus 4 times 0. Well, 0 squared is 0 times 3 is still 0. Minus 4 times 0 is 0. So you're just left with 0 there. And wants me to find f of -1. So now I'm going to replace my x's with -1. So I have 3 times -1 squared minus 4 times -1. Be careful with your signs. -1 squared turns into +1. So I have 3 times 1 here, which is just 3. What's -4 times -1? Turns to +4, which gives me 7. And then the last one it wants me to find is f of 2. So same process. I'm just going in and replacing my x's with 2's. So I have 3 times 2 squared minus 4 times 2. So 2 squared gives me 4. So now I have 3 times 4, which gives me 12. Minus 4 times 2, so minus 8. And 12 minus 8 gives me 4. All right, number 6. More graphing. The only thing that's different between these and the ones we did at the very beginning is it gives us the list of the x's that it wants us to use. Okay, so on this next one, f of x equals -4 plus the absolute value of x. And then it gives us the chart with the x's already filled in. So the first thing you have to do is find the y's that go with each of those x values. And remember, again, that's as simple as putting the function in your y equals and go to the table and just get the y's that go with each of those x's. So in my y equals, -4 minus, not minus, excuse me, -4 plus, and remember where absolute value is, math, button, over to number, enter, and then put in your x. So since it's absolute value, it is going to be another V shape. So go to second table. So there's all the x's and y's that you need. So let's see, with -2 goes -2, -1, -3, 0, -4, 1, -3, and 2, -2. So again, when you're doing absolute values, what are you plotting first? Vertex, that's right. And you can even tell from this chart what the vertex is. It's the point that's in between where they start mirroring each other. You can either look at the picture in your graph and see that it's the point where x is 0 and y is -3. -4. So that's the point you're going to plot first. 0, -4. And then on either side of that, -1, -3, and +1, -3. Number 7, -x² minus 5. So this is going to give us the same XY chart with the same X values to fill in before we graph. So go to Y equals, clear it out. This one's -x² minus 5. Again, it's an x² graph, which means it's going to be a parabola. It's just upside down since the x² is negative. So go to second table and complete this chart. So this time with -2 is -9, -1 is -6, 0, -5, and then it starts mirroring itself after that. Parabolas also have vertexes, just like the absolute value graph. This doesn't, I guess, MATLAB doesn't make you plot the vertex first, but if I did, which one of these points would it be?
0,
Good, right. Inside where the mirroring starts. So 0, -5. And then either side of that, -1, -6, and +1, -6. All right, on number 8, it's going to ask us if the graph is a function or not. It's the picture of the graph now. Instead of listing domain and range, it's going to give us the picture. And remember the test that we use when it gives us the picture of a graph and asks if it's a function, that means to use your vertical line test. And remember what the vertical line test says. If you can draw a vertical line, which is the one that goes straight up and down, and touch the graph more than once, it is not a function. Okay, so vertical line, more than once, not a function. This graph looks like this. So is that a function? No, right? Because if you draw a vertical line right here, you touch it twice. So not a function. Number 9. Okay, so it looks something like this, and it's going to ask us 4 different questions. Okay. The first thing it's going to ask me is, what is f of 2? Now remember, what's in the parentheses is your x. So what this is asking me is what happens on the graph, or what is this y when your x value is 2. So let's see, if I go to 2 on the x-axis, which is right here, and then draw, hang on, let me make sure I do this right. Yeah, draw a vertical line. Everywhere on that vertical line, x is 2. Where does it touch the graph? Right here, which is also what? 2. 2 for the y, if I drew it. Looks like I did. Right? Yours will have those lines that you'll be able to see exactly. Then it's going to ask me, what is the domain of this function? Which means, does it go forever left and right, or is there a stoppage somewhere? Talking about left and right. What does this half of the graph do? Go forever? Negative infinity. Right. Goes forever to the left. What does this half of the graph do? Goes forever to the right. Is there any point where it stops going left or right? No. Which means, yes, in interval notation, it would be negative infinity to positive infinity. This is multiple choice, and it calls it all real numbers. But it's the same thing. Okay. Yeah. Okay, the next part is talking about y's. So if f of x equals 1. So it's trying to find the x's that go with y being 1. So go to your y-axis, find the 1. Everywhere on this line, y is 1. Right? Because every point on that horizontal line I just drew is up 1. So let's see, where does it touch the graph? Here and here, right? It touches it twice. So what is the x value here? 3. And what is the x value here? 5. So it touches it at 3 and 5. Now, the range is the y values. Does this graph go forever up and down? No, it doesn't go forever down. It stops going down right here, right? And then it goes back up. So let's see, I need to know what the y value is at this point, because that's what the range is the y values. The x is 1, 2, 3, 4, but what's the y? Yeah. It's 0. 0 is the very lowest point in the range. So how am I going to say that in the not interval notation? It would be greater than or equal to 0, or 0 to infinity would be interval notation, right? But here, y is going to be greater than or equal to 0. Right, number 10 is going to give us a function or correspondence and ask us to find the domain. So you have g of x equals 6 over 2 minus 9x. So this domain, we were just looking at the picture, seeing how far left and right it goes. I don't have to draw the picture. I can just look for restrictions in the function, which would have to deal with this x in the denominator, right? Because what can your denominator not equal, right? So you just say the denominator, which is 2 minus 9x, can't equal 0, and then solve it for that x. So subtract the 2. So now I have negative 9x. Can't equal 0 minus 2, which is negative 2, and then divide that by negative 9. So x can't equal negative 2 over negative 9, which just makes it positive 2/9. All right, this next section is going to go back and do where it gives us two functions and either asks us to add them together, subtract them, multiply them, or divide them. On number 11, the functions are f of x equals negative 11x plus 13. And g of x equals x squared plus 2. And it's going to ask us to find f of 10 over g of 10. Okay, so what I'm going to do is find f of 10 and g of 10, and then put my f answer over my g answer and reduce that number if possible. So f of 10 gives me negative 11 times 10 plus 13. Negative 11 times 10 is negative 110 plus 13. What does that give me? Negative 97. So now do the same thing with the g function. I'm going to find g of 10. Which is going to be 10 squared plus 2. Good. 10 squared is 100. Plus 2 gives me 102. So if I put my f over my g, I have negative 97 over 102. If you're not sure if that reduces or not, remember how you can do that in your calculator? Just type in exactly what your answer is. Negative 97 divided by 102. You get a decimal. So see if that fraction reduces by hitting your math button and then hit enter twice. So if it reduces, it would have given you the reduced answer right here, but it still says negative 97 over 102, which just means that is its simplest form. Number 12. F of x is negative 5x plus 4. G of x is x squared minus 2. It wants me to find g minus f of x. So I don't need to replace the x's with any numbers, right? Because it is x. So I'm just going to find my g function, which is x squared minus 2, minus my f function. Now remember, I don't want to just subtract part of the f function. I want to subtract the whole thing, which means what am I going to have to put around this whole function? Parentheses. So minus the whole function, which is negative 5x plus 4. Distribute this negative to remove those parentheses. That's your subtracting part. So I have x squared minus 2. That turns that to plus 5x minus 4. And then you're just combining like terms. This would be this negative 2 with that negative 4. So I'll have x squared plus 5x. Negative 2 minus 4 gives me negative 6. All right, number 13. F of x is x squared minus 20. G of x is 19 minus x. It wants us to find f minus g of negative 10 this time. So I'll find f of negative 10, g of negative 10, and then subtract my answer. So f of negative 10. So I'll go to my f function and replace its x with negative 10. So negative 10 squared minus 20. So negative 10 squared is positive 100 minus 20 gives me 80. G of negative 10. Be careful here with your signs. 19, then minus. Then what are you subtracting? What are you putting in place of this x? Negative 10. So what does this actually mean you're ending up doing? Adding. So 19 plus 10, which gives me 29. And what does it want me to do with those numbers? Subtract them. So 80 minus 29 gives me 51. From the f of negative 10. Right? Because remember, the first thing you had to do was find f of negative 10. So if you put negative 10 here, negative 10 squared, put parentheses around your negative 10. Because, are you getting negative 100 when you do it? Did you do minus? So if you did you do? Yeah, because if you don't put negative 10 in parentheses in your calculator and you just put this, what it's actually telling you to square is 10 and bring down the negative. So this is negative 100. But if you're squaring negative 10, which is what we're doing, you need parentheses around it. All right, number 14. F of x is 1 over x minus 8. G of x is 9x to the third. Now, it's going to want me to find the domain of 3 different things. The domain of the sum of those functions, the domain of the difference of those functions, and the domain of the product of those functions. Okay, now remember, when we're talking about domain, we're thinking, what can x not be? Because then it can be everything else but that number or numbers. The sum would mean you are adding those two functions together. If I add those two functions together, I'm still going to have x minus 8 in my denominator. Okay, if you subtract this function minus this function, I'm still going to have x minus 8 as my denominator. Product means multiplying these. If I multiplied those two functions together, I'm still going to have x minus 8 as my denominator. So the domain of these three things are all going to be the same. All you have to do is look at your two original functions and find any restrictions in either one of those. Okay, 9x to the third doesn't have any restrictions, but this has an x in my denominator, so x minus 8 can't equal 0. Solve it. So add 8 to both sides. So x can't equal positive 8. So the domain for all three of these is x is a real number and then it gives you a blank right there. You have to just type in x can't equal 8. And you have to type in that whole thing. You can't just put an 8 in that spot. You have to type in x can't equal 8 That can't equal symbol will be down in your toolbox on that question. So yes, it'll be 3 different questions. They will all be that same exact answer. 15. F of x is 3x minus 7. G of x is 7x minus 42. And it wants me to find the domain of f over g. So put the f function over the g function. So that'll be 3x minus 7 over 7x, bless you, minus 42. So what is the domain of this? That means to do what? Your denominator can't equal 0. And then solve it for x. So add the 42. So 7x can't equal 42. Divide by 7. So x is a real number and x can't equal 6. All right, number 16. This is getting into the composition of functions. So f of x equals 3x minus 7. Oh, no. That was the last one. F of x equals 4x plus 3. G of x equals x to the 3rd. And it wants me to find f of g of negative 4. So remember, when you're finding composition of functions, what is in that position is what you find first. So I'm finding g of negative 4, which just means go to g, replace its x with negative 4. So if I do that, I have negative 4 to the 3rd, which gives me negative 64. So then what happens is you bring down this f and replace its x with what you got on your last answer, which is negative 64. So go to f and replace its x with negative 64. So 4 times negative 64, which gives me negative 256, 253, yeah. Plus bring down the 3, which gives me negative 253. We'll end with this one. This is, we'll do the rest next class. F of x is 9 over 1 minus 5x. G of x is 1 over x. This one has a lot of parts to it. First thing we're going to do is find f of g of x and its domain. So just like the last one, whatever's in this position is what you find first. So the first thing I'm doing is finding g of x. What is g of x? 1 over x. Just like the last one, what am I doing? Now I'm going to the f function and replacing its x with what I got in the last part of my answer, which is 1 over x. So this means to go to F, what are you going to put in place of this X? 1 over X. So I have 9 over 1 minus 5. That's where I'm going to put the 1 over X. So now I've got to multiply right here. So I'll just bring down the 9. Then I have 1 minus. Now remember, when you're multiplying fractions together, that's the easy operation, because you just multiply your numerators together and your denominators together. You don't have to get a like term, they don't have to be common denominators or anything. So what are you going to get when you multiply here on top? 5 over, what's in the bottom? X. 1 times X, which is X. So I have 1 minus 5 over X. Now it's going to say this fraction is too complicated because it has a fraction within the fraction. And remember how we fix that. Whatever this denominator is of this fraction that's inside, that's what you're going to multiply the top and the bottom by. Because look what happens if I multiply by X times X, X over X. Up top, 9 times X, 9X. In the bottom, this X goes to both of these. What's X times 1? X minus, here's why we use it, because now what happens when I multiply this 5 over X times X? What happens to these X's? They cancel. So I just have X minus 5. Okay, now I have to find the domain of this. There's 2 places that you're going to look for restrictions. Your final answer. So there is a restriction there, right? Because X minus 5 can equal 0. The other place you look for a restriction is right here. What you plugged in to get to that final answer, and it has an X in its denominator too. So this denominator, which is this X, can't equal 0. Solve this. So just add the 5 to both sides. So X can't equal 5. This one's already solved. X can't equal 0. This, it is multiple choice, but it's going to give us this domain in interval notation. Put the numbers that X can't be on the number line. 0 would be here. 5 would be there. So there's 3 separate intervals. Those numbers, then the numbers between 0 and 5, and then the numbers above 5. So I'm going to have 3 separate intervals. This first one's going to be negative infinity until I get to 0, and, which is the U, in between 0 and 5, so 0 to 5, and 5 to infinity. And we're going to start all over because that was F of G. So now what do we got to find? G of F. This is why we're stopping on this problem. So our Friday shouldn't be too bad. We've done most of the hard work. G of F of X. So this time, what are we finding first? F, right? And what is F of X? It tells you right there. It's 9 over 1 minus 5x. So now what do we got to find? G of that last answer, which was 9 over 1 minus 5x. So this says go to G. And what am I going to put in the denominator instead of x? I'm going to put all that. So I'm going to have 1 over, this replaces your x. So 9 over 1 minus 5x. Now remember, this fraction's too complicated because it's got a fraction inside my fraction. And how do I cancel this denominator? Right, that's exactly, I use that denominator and multiply. So here, 1 times 1 minus 5x is just minus 5x. What happens in the bottom? That one cancels that one. So all I have is 9. That's that final answer. So now I just need to find its domain. Here's my final answer. That's the first place I look. It's a fraction, but it doesn't have any restrictions because it doesn't have any x's in its denominator. So no restrictions there. Now remember the other place you're looking is this right here where you plugged in. This does have a restriction because its denominator, which is 1 minus 5x, can't equal 0. Solve it for x. So subtract the 1. So negative 5x can't equal negative 1 and divide by negative 5. So x can't equal that negative over negative turns to positive 1/5. So there's only one restriction. 1/5, which means this one's just going to have 2 intervals. The numbers below 1/5 and the numbers above 1/5. So the first interval is negative infinity to 1/5. And the second interval is 1/5 to infinity. Okay, so we will start there at number 18 in next class.